Good afternoon, everybody. Welcome to class today. Thank you for joining me, whether you're watching live or you're watching the recording. I appreciate you all watching. So this is week 2 of our 2-week module here, and we were covering recursion and value functions. So my goal for this afternoon is just to do a few quick examples, just so we can have some more information about what value functions are and how value functions work, and then do a couple examples of recursion. So I just want to code around a little bit today and do a little bit of coding today. And up until this point in the course, we're kind of used to writing functions that look like my main method here, which is the public static void. And when you hear people talking about void functions versus value functions, or fruitless functions versus fruitful functions, that's where we get into the kind of concepts that we're talking about today. We see these 3 terms here: public, static, and void. And these are 3 terms that we are used to using. And we kind of mentioned in the past what these 3 terms mean to our function, but we didn't really get into it. Right, the first term here, public, is an access modifier. And so this access modifier, it specifies what can access this method. Right, if I have a public function, then it can be accessed from any class or any other program. So if I wanted to take this program and import it into another program, if the function was public, then it's extensible. But I could also have a private function, and a private function is only accessible within the class that it was declared. So if I want to have a function with a private access modifier, then I can only access it in this particular class in this particular file. Next to it is the keyword static. Static is the non-access modifier. And this basically just means that the method belongs to this class, right? So I can have a public static void, or I can have a private static, or I could even just have a public or a private void or value function. Now, the difference between having a static function and having a non-static function or a function without this static keyword is just what we have to do with it when we call it. So if I have a function that is static and I am calling it inside of the class, then I don't need another object or anything else to hold the data. If I do make a function that is not static, if I just make a, say, private void new function, then in order to run that function, right, if I were to system.out.println here, hello world, if I were to try to run this new function here in main without doing anything special to it, it's going to error out. It's simply going to error out because I didn't put the semicolon at the end of it, but it's still going to error out because it's telling me that it is expecting something different. Right? It expected an identifier for new when I called the function here. Now, if I made an object of the main class, say something like main O equals new main, and then did O dot, then I should have, And what I'm probably missing here actually is this should probably be a public instead of a private. Let's make this a public. And let's just change the name of it. Yeah, that's the problem because I'm using the word new. This can be a private as long as I don't use the word new. New is a reserved keyword. Right, so private void n system.out.println. And if I just try to make this the in function call here, that's not going to work because it cannot be referenced from a static context. So if we make an object of our main method, main o equals new main, that's going to create an instance in the main class through memory through which this can run. So I can take that object name and add it onto there, and then it's going to run, right? So that's the difference between having that static value and that non-static value. If I were to run private static void m and print like system.out.println, hi there, I don't need that object to call that function. I can just call m because it is a static method, which means that this already belongs to this class. I don't have to put it in this class. And it would help if I remembered my semicolon at the end. That's what happens when you program in too many different languages in a given semester. And then we get to the word void here, and this is where we start to diverge, right? Because a void function means that there is nothing returned from the function. With a void function, we are printing out the information inside of the function, which is in contrast to a value function, because in a value function, you return information back. Right, so like we talked about parameters before, and we kind of compared them to like the pneumatic tubes at the bank, and to where like I could put something in the pneumatic tube and that would take it into the bank. Right, with a value function, on the other hand, what that's going to do is that's going to send something back out of the bank for me. Right, so it's going to be able to take a value from this function and send it back out, so that it can be used in another function, or that it can be used in main, or something else can happen with it. Right, so one of the things that we could do here is we could have a string function. So we could have something that is, say, public, static, and string. Uppercase S in string here, right? Everything else is lowercase except for string. And we'll call this, we've got m and n, let's do A, right? This will be function A. So now we've got function A here. We see we're not bringing any parameters into it, but we do have this string keyword here. And with a string keyword, in our function declaration, that makes it a string value function, which means it has to return a string. So if we want to get rid of this red squiggle that we see here under our function name right now, what we would want to do is we'd want to write what we call a stub here. Right, so I'm just going to put return and a set of empty quotes. Right there, because that set of empty quotes is, in essence, a string. It's just not a string that we might want to use. Right, and when we add that return statement with the empty quotes, that red squiggle goes away. And that red squiggle goes away because we've fulfilled our promise. Right, when we put this data type here, whatever data type this is, when we put that data type there, we're essentially making a promise to our compiler. And that compiler is that we are going, or that promise is that we are going to return a value that is that data type outside of the function. So it's going to be looking for that data type value. And if it's not getting it, it's going to have a problem, and it's going to throw a little bit of a fit. So I want to make sure that I start with this stub so that I can do some incremental testing, and it doesn't really impact things. It doesn't really bother things. Right, so let's say I wanted to just basically be able to pass a message to this this function, and in that function, just get it to be able to return back out a greeting to a person. Right, so let's import our scanner, right? So we can import java.util.scanner. And let's make ourselves a scanner object at the class level, right? So we can use it in multiple functions later on down the line. So I'll use public so it's accessible by anything. I'll use static so it belongs to the class. I'll use the scanner object name in equals new scanner on system.in. And so now that this is at the class level, it is static, so it belongs to the class. I could also just say public scanner, but if I did that, right, I'm going to need an object to associate it with that. So we're going to put public static there. And now let's say inside of our main method here, we just print out a message to our user. Let's comment out these lines really quickly so they don't print. Let's system.out.print a message for our user. Enter your name. And there we will take string user underscore name, or user camel case name, equals n dot next line. That's weird behavior. And then we can pass off that, and we should actually make that as an object since we use string objects. So that should be a new string of n.nextLine. And then we could take that username and we could pass it off to our a function down here. So that'll be a. We'll have to have some sort of parameter, right? So we'll need to add a string parameter here. I'll add a string parameter for uname. And so we'll call a user name. Now, if we just did this, right, we could do this and we could have it return back out. Since that's going to be a string, we can have it return back out the username. So we can have it return back out uname. But one of the important things to look at here is the fact that this return statement is not a print statement. It is not a statement like this that does a print. So what we want to do instead which we'll see if we run this here, right? It's going to ask our user to enter their name. I'll enter my name, Mr. Ramsey. And then it does nothing. because it's just returning the value. It's not doing anything with it, right? So what I need to be able to do is I need to be able to do something with it. So what I would do is I would actually print the results of this function. So instead of just having a string inside of a print statement, I could put a reference to another function inside of that print statement, and that print statement would spit out my result. Right? So the key thing here is this idea that this is just data. And in order to get that information, you have to do something with it. And so we can print it out here. And so the value of that would come into where when I'm using other information or other functions that might want to take that information and do different things with it. Right? Because then I can put that into a variable, I can print it out, I can put it as a parameter in another function. And when we see something like this, we're normally used to working from left to right. But in this instance, what we need to do is we need to work inside out. Right? So we need to start on the inside, and the flow of execution goes outward. So it's going to go and find the username value, which is here on line 12. Grab that and put it in here. Then it's going to go back out to the next level, which is the call to the A function. And it's going to run the A function. So this is our A function. Parameters uname, which is username here. So username becomes uname, and it just returns uname. And so that takes that data, returns it back out, and replaces this whole function call. Which it in turn just prints out, right, as a part of the print line function here. So if I wanted to write something that I could do with this would be to, say, concatenate something onto it, right? And I could concatenate something like hello uname, right? As long as it's still a string, it's just fine because I've made that promise. The promise I've made is a string is going to be returned out of here. I am returning a string out of here, so it's going to be just fine. All right, so if I run this, I can write a hello world. I can write my name. And it's going to give me that information. And it didn't put the space in there because I didn't put the space in here, right? And so that becomes pretty cool, right? Like we'd use an integer function for values, for integer values, a double function for double values, a Boolean function for Boolean values. Whatever type of value we're planning on outputting is the type of function that we would use. Now, another important thing to note here, right, is that if we go and try to put any code under a return statement, it becomes unreachable. Right, you see that red squiggle pop up there. That line of code is unreachable, which means my compiler will never get there to run that code, because whenever the compiler hits a return statement, it is done with that function. Right, so if I were to run this, it's going to throw me an unreachable statement error, because this code is unreachable. So let's see another example of this, and let's talk about a way that we could use this with recursion. right? And first we can kind of talk about what recursion is. So I think we kind of mentioned recursion previously. Now we talked about how recursion was kind of like two mirrors facing one another. You know, I put a reference to a function inside of itself, and it sort of bubbles up and keeps going until it hits some sort of condition point. Right, so what's interesting with recursion for a void or for a value function is that I am going to, instead of printing out a value multiple times and then changing and then recalling the same function, I'm going to be calling the function in the return statement. Right, which makes things a little bit different when I do that, right? So if I had, say, a public static int function, an int would be an integer, and we'll call this a count down function. We'd need to bring some value in, so this would be like int I. And we would need to go ahead and return 0 to complete our stub, so it doesn't throw us that little error there. And so one of the interesting things that I want to do with this is I want to take this function and I want to work with it a little bit here. Right, so we'd add, say, a conditional statement in here and say something like if I is greater than 0, then we can return countdown I minus 1. Right, and one of the issues that we see here, right, is that we see that countdown, our function call there, has a little squiggle under it, right? And that's because not all paths return a value. If you write a value function with a conditional in it, or with a loop in it, or something like that, every branch on that path must return something. So if I wrote something here that said like else return 0, now that I've satisfied that else condition with a return statement, and both branches, there's two different pathways to return, I can look at that function in a little more depth. So let's comment out these lines here. And let's run that function. Right, so let's run countdown. Let's actually print countdown. System.out.print line countdown 10. And let's see what happens here when we do this. We print out 0. And why did we do that? Remember, just like we just spoke of, the return statement on its own doesn't do anything to the values. Right, so if we actually wanted to do something with the value here, we would need to maybe print something out. From inside the value function. Now remember, we have to do that before the return statement, or else it'll be unreachable. Let's see what happens if we do this. There we go. That gives us what we want. That gives us the recursive method that we want here. We're calling the function within our function. We have a pathway out. We have it returned out if we need to reach our pathway out. We're good. Right? And we get the countdown on the output. So we can do recursion with value functions just like we could do recursion with void functions. It's just slightly different. Just slightly different. Now, let's say I were to take a function here, and let's just write another value function. Let's write it recursively, even though since you all have the power of some loops now, if I recall correctly, right, we did in the last, well, no, we really haven't yet. Loops are module 7. So let's look at a function to where we take a number and we add it, say, to another number, right, and see what we can do there. Let's say we took all of the even numbers between number A and number B, and we added them together and gave us a result. So in this case, what I might want to do is write a function called public. And let's make this not static. Let's make this not static just for fun, just so we can use our object again. We'll make this public int. We'll call it even sum. And we'll have an integer value here, which is our top number. So what we want to do here is we want to we'll go ahead and return 0 here, just to have our stub. So while we're thinking about this, we don't have that big red squiggle line under there. So what I want to do is I want to have a number entered in here, right? Say a user enters in a number. And I want it to be every even number from x, from 0 to x. Right, so if the number is even, I want to keep a running tally of it. If it is odd, I want to get rid of it or not do anything with it. Right, so this can be a bit of a challenge, right? Because we're trying to think about how to add numbers together, which is in and of itself a bit of a challenge when we are doing recursion, but we're also skipping numbers. So what I really want to do is I want to check to see if some value or if top num is greater than 0. Right, so if top num is greater than 0, what are we going to do? Well, the first thing that we're going to do is we're going to check to see if top num is an even number. Right, so we'll nest a condition in there, and we'll say something like if top num modulo 2 is 0. So what if it is? Right, if it is, well, let's take even sum top num and add it to even sum I don't think this is what I want to do. I don't think that's what I want to do. Hold on. I'm working without I'm working without my notes right now. Let me pull up my notes here. Let's see here. Where are those? Where are all those notes? You know what? It would just help me if I had another number here. That would just be like int botnum. I haven't found my notes here yet, but so in this case, it would be if int botnum is greater, or if int topnum is greater than int botnum. What I would want to do is I'd write this statement here. If it starts out that way, actually, what I might want to do is just go ahead and return 0. And then an else statement. So then we'd actually pull this out of here. Right, because we could start out with a value that is bigger. And so if we were to start out with a value that is bigger, than what we have, then we just want to immediately return 0. And so everything else would be kind of working that way. So from there, we could take our else statement, and it's in our else statement where we would check to see if our botnum modulo 2 is equal to 0. In which case, if it is, we would want to return and it would help if I wrote in the right language here. We would return the current botnum plus even sum botnum plus 2, right? Because we wouldn't have to check the odd numbers because we could just skip to the next even number because we know it's an even number. And keep the top number flowing through. Right? Which is a good trick to all of this, is if we keep the top number, or if we're using something where we have a value that we're referencing, if we keep the reference value going through, then it's always going to stay the same. It's always going to make things easy. Right, so that will take our current number and add it to the results of this. Right, and it's going to bubble up. Now we see we have this squiggle here because every path does not have a return statement on it. So I need an else statement to go with this if statement that has a return statement on it. In which case, we're going to just increment this by 1 because it is not on a even number. It'd be on an odd number, right? Because the odd number check came back, or the even number check came back false. Right, so I'm going to return botnum plus, or I'm actually just going to return even sum botnum plus 1 topnum. And that's my algorithm. That's the algorithm that I would use to add every even number together from 0 to a top number, right? Now notice that we are not printing out all the values here, right? We're just going to be able to get and print out the last value. So in order to actually use this function, since we didn't make it a static function, we need to take advantage of our object that we made earlier. And we'll say O dot even sum. We'll say between 0 and 4 to test it out. Now, if we were to run this, we wouldn't get any answer out of the result, right? Because everything here is just returned. So I would need to be able to system.out.print this result. We'll do system.out.print line. Or I could store it into a variable that I could print out, right? There are multiple different ways that I could use what is returned out of this sum. But we should get, if we clear out this console here, we should be able to run this, and we should be able to get, well, we got 0 on our output. I wonder what we did wrong here. I wonder what we did wrong. Well, I guess it's because the last thing that we're returning out of the function is what we're returning out of the function here. But it should still bubble up. If top num is greater than bottom num. Oh, you know what I did? I inverted my logic here. That's the problem. That should be if bot num is greater than top num. That's what happens when it's late in the day. Right? Of course top num is going to be greater than bottom num. That's always going to happen. I need to see if bottom num is greater than top num. Duh. Then we get 6 like we're supposed to. Because that would be 2 plus 4, right? And so if we had 10 as our big number here, we'd get 2 plus 4 plus 6 plus 8 plus 10. 2 plus 4 is 6, plus 6 is 12, plus 8 is 20, plus 10 is 30, which is exactly what we get on the output. And since we're using recursion here, this is O1 time. So we could put a pretty big number in here, like say 100. It doesn't seem like it's a big number, but we're adding all the even numbers between 0 and 100, right? So we should be able to run this, and we'd get a pretty big number on the output, 2,550. Right, we could even do real big numbers. We'll do 10,000 here, and since it's recursive and not iterative, it's O1 time. It's going to give us that result pretty quickly. Right, let's do all even numbers between 0 and, let's say, 1,000,000. Oh, I think we hit a peak there. Yeah, we got a Stack Overflow there. We did a little too much for the memory there. 100,000 is too much. Looks like around 10,000 for our memory. It's about where we want to live for this problem, but we see it adds all those numbers within 2 seconds there, which is way faster than the speed at which you can add them. So that's what we've got. So those are the things that I wanted to show you all today. I think that's pretty much it. There were some other examples and stuff in last week's video that I posted, so you'll want to make sure that you go back and watch that as well. If you've got any questions, you can go ahead and drop them into the chat now. If you are watching the recording, please, if you have a question, send me an email or a Teams message. But that's all that I have for you for today. Thank you for watching, and we'll see you next time.